So in the previous example, the relationship was exact. And the previous example was cooked pretty hard to give us an exact relationship, right? In the previous example, we were literally adding water to the same fish tank, right? So the weight was the weight of the fish tank plus the weight of however many gallons of water. And a gallon of water has a constant weight of 8 pounds. So that gave us a perfectly linear relationship just because of the way that it was set up. Most things in real life are messier than that. Even perfect relationships are going to be messy because in real life measurement is also not exact. But most relationships in real life are not quite exact. Right? So like suppose we buy a car that is advertised as getting 20 miles to the gallon. And we think X represents the distance we drive in miles, Y represents the amount of gas we used in gallons. So if we don't drive anywhere, we don't use any gas. But then 20 miles to the gallon means every time we drive 20 miles, we use 1 gallon of gas. So if we drive 20 miles, we use 1 gallon. If we drive 40 miles, we use 2 gallons. And this will give us an exactly linear relationship. The slope is the change in y over the change in x. The intercept is the value of y when x is 0. So this is our value of b. And so this relationship is described by the equation 1/20th x. And we could write in plus 0, just so we know we didn't forget about the intercept. But when we work with this equation, we can just say 1/20th x, because adding 0 doesn't do anything. Unfortunately, real life isn't that tidy. Lots and lots of things affect our gas mileage. Stoplights, wind, hills, just exactly how we drive, how we brake. The car that gets 20 miles to the gallon might generate data that looks more like this. So suppose we take several trips of various lengths. Let's see what kind of scatter plot this generates. And again, in the example, we have screenshots of the whole process, but I'm going to walk you through it again on the calculator. So first we hit Stat, Edit. We can clear out the numbers from the previous example. We'll enter the X values in L1. So those represent distances. We'll enter the Y values in L2. Those represent amounts of gas. We'll give this a quick proofread. And then we're going to make a scatter plot. So to make a scatter plot, we hit second followed by y equals to get the stat plots menu. We choose plot 1 and turn it on. And now at this point, this is set to a scatter plot for L1 and L2 from the previous example. We'll say zoom and choose zoom stat. And here's our scatter plot. Looking at the graph then, we see that these points don't lie exactly along a line, but we see that they're pretty close to a line. We can imagine drawing a straight line along the middle of this graph. it would look something like this. And those points are scattered pretty closely to that straight line. And in fact, going back to the calculator again, we can try drawing the graph of that equation we had earlier. So I'm going to hit y equals, and I'm going to just enter that equation. Y equals 1/20th x. And just hit graph to go back to the graph. And we see that the graph of that equation, y equals 1/20th x, lies pretty closely down the middle of that scatter plot. The way we describe this is that this line is a good fit to the data in the scatter plot. Now, the next question is, how would we come up with that equation given just the data, just the scatter plot? Remember, we came up with that y equals 1/20th x because we were told that the car got 20 miles to the gallon. If we were not told what the car's gas mileage was, how could we figure out that line? And therefore, that would then let us figure out the car's gas mileage. So that's going to be our next idea. How do we go from just a data set to the best possible line through the middle of that data set?